Hello everyone, Mr. Linder here. Let's talk about urinary functions and processes. So before we get into functions and processes, let's take a quick look at the anatomy of the urinary system. So from a gross anatomy standpoint, the urinary system is very simple. 2 kidneys, 2 ureters, a urinary bladder, and a urethra. Most of the complexity comes into play when we look at the internal structures of the kidneys. And really, it's the kidneys that provide the functionality of the urinary system. So on this particular diagram, you can see that the kidneys have a good blood supply. So the renal artery feeds into the kidneys. And then there are branches of the arterial system. And then you have venous blood that's going to flow out of the kidney and leave the kidney as the renal vein. This structure is the ureter. And the ureter is what's going to carry urine to the urinary bladder. So the kidneys are actually producing urine, and they're processing the blood that comes into it. And then the urine is leaving through the ureter, and it's being collected in the urinary bladder. In order to process the cardiovascular blood that comes in, and in order to produce urine, there needs to be structures within the kidney that can perform that task. So if we look at the kidney in more detail, we have the renal capsule, and then underneath the renal capsule is the cortex, and then deep to that is the medulla. And in the cortex, you'll notice that there are tiny blood vessels, and the vessels branching off are called the afferent arterioles, and those afferent arterioles are feeding into a structure called the nephron. And so there are millions of nephrons inside of the kidney that are performing the functions for the kidney. So let's zoom in on that. So on this diagram, you can see, again, afferent arteriole. The vessel leaving is the efferent arteriole. And then we have the Bowman's capsule, also called the glomerular capsule. So Bowman's capsule. Connected to that is the proximal convoluted tubule. We have the nephron loop, also called the loop of Henle. Connected to the loop of Henle is the distal convoluted tubule, and then that connects to the collecting duct, which is where urine is being collected. And then that'll go into your calyces and your renal pelvis, and eventually into the ureter. Surrounding the nephrons, there are paratubular capillaries. There's also vasa recta capillaries that are deeper into the medulla. And these are going to be working along with the nephron as we process material in the attempt to generate urine. If we were to stretch out the nephron, so give it a different look here. Here we have the afferent arteriole again, the efferent arteriole. Now we can actually see the glomerular capillaries inside. So there's the glomerulus surrounded by Bowman's capsule, connected to the proximal convoluted tubule, the nephron loop or loop of Henle, distal convoluted tubule, and then the collecting duct. So these are the main structures of the nephron. And the nephron are these microscopic tubule systems that are going to be involved in the processes that take place within the kidney. So filtration, reabsorption, and secretion. So let's look at, though, the general functions of the kidneys. Really, if we're looking at urinary system functions, we tend to focus on what do the kidneys actually do. So it's often stated that waste removal is the most important function of the kidney. And waste removal is important, but I would argue that regulation of water and electrolyte balance is actually more important. It turns out that fluid and electrolyte disturbances will actually cause more serious problems before the accumulation of waste will actually lead to toxicity in the body. So although waste removal is important, it could take a long time for waste accumulation to lead to death before an electrolyte imbalance or a water imbalance could lead to death. So the kidneys have to balance the intake and the excretion, and so they have to obey the mass balance principles of homeostasis. The general functions of the kidneys include, number one, regulating extracellular fluid volume and pressure, so making sure that we regulate the volume and blood pressure within the extracellular fluid. So that means that the urinary system is working with the cardiovascular system to ensure that we have proper blood pressure and blood volume. When fluid volume decreases, we know that blood pressure decreases, and so it would be difficult to maintain adequate pressure to organs of the body and to keep them functioning. So the urinary system is working closely with the cardiovascular system to make sure that this volume and pressure is maintained. Second function of the kidneys is to regulate the osmolarity, or we could say the osmolality of the cardiovascular system. And so basically the kidneys are monitoring and making sure that the concentration of water and electrolytes is appropriate so that we can essentially maintain the proper concentration within the cardiovascular system. This oftentimes is going to involve renin, which is a hormone from the kidneys, which is going to affect angiotensin II concentrations. It's also going to affect antidiuretic hormone, and it's also going to affect how thirsty we get and how much fluid intake we are taking in. So monitoring the concentration is a very important function for the kidneys and the overall function of the urinary system. Third thing to take a look at is maintaining ion balance. So the kidneys are ensuring essentially that electrolyte balance is maintained. This is going to be maintaining sodium levels, potassium levels, bicarbonate levels, hydrogen ion levels, chloride levels, and so forth. So lots of different electrolytes that need to be monitored and ensure that we have the proper balance within the cardiovascular system, as well as what we're excreting or losing from the body. The fourth thing to take a look at is homeostatic balance of pH. And so pH balance actually goes right along with electrolyte balance because we can maintain pH balance by the retention or removal of hydrogen ions and bicarbonate. So how much hydrogen we hold on to, how much bicarbonate we hold on to, how much we excrete from the body, this will determine what the overall cardiovascular pH is going to be. So we can assist in pH balance through the retention or removal of these particular ions. The fifth thing to consider in terms of function of the kidneys and function of the urinary system would be waste removal. Waste removal comes in different forms. There are different types of waste that we need to get rid of from the body. So in essence, the kidneys remove foreign substances. So we're going to remove drugs. So whether we take in antibiotics, whether we are using over-the-counter medications, waste removal of foreign substances is important. We're also getting rid of artificial sweeteners. We're getting rid of food preservatives. And so, waste removal comes in different forms when you're looking at foreign substances that are within our blood. The primary metabolic waste, though, that we get rid of is urea. So waste removal of urea is important. We also get rid of uric acid, another metabolite in the body. And then we also get rid of creatinine, which is another metabolite that we need to remove from the cardiovascular system. We also will see removal of things like urobilinogen, which is a a byproduct of hemoglobin metabolism. You'll also see hormones removed from the body through the urinary system. And then, of course, we are, again, removing basically anything that ends up in the cardiovascular system that is foreign and shouldn't remain within the blood. So lots of waste removal takes place through the kidneys. The last thing to take a look at in terms of functions of the kidneys would be hormone release. So there are several hormones that the kidney produces or activates, one of them being EPO, erythropoietin. So the kidneys synthesize and release erythropoietin, and the purpose of that is to increase red blood cell count. So EPO affects the bone marrow. The kidneys also synthesize and release a hormone called renin. Renin is actually used to activate the angiotensinogen pathway. And this is going to aid in sodium and potassium balance. It's going to aid in blood pressure and water volume maintenance. So lots of things to do with the hormone renin, lots of functionality. And then there's also enzymes within the kidney that are going to activate vitamin D. And these vitamin D precursors can be converted into calcitriol. And calcitriol is a hormone used for calcium balance. So it aids in calcium absorption. So we have lots of different functionality of the kidneys in order to provide various physiological functions for the human body. How does the kidney accomplish these tasks? So there are processes that the kidney goes through in order to accomplish these various functions. The basic processes are known as filtration. So letter F for filtration on this diagram, reabsorption, letter R, and secretion. So those are the three basic processes: filtration, reabsorption, and secretion. And those processes are going to determine what gets excreted to the outside of the body. So what is filtration? Filtration is the movement of water and solutes and foreign substances from our blood into the Bowman's capsule. So basically moving material from the cardiovascular system, leaving the glomerulus, and entering Bowman's capsule. So that is filtration as a mechanism. Filtration basically generates what we call filtrate, and then filtrate gets processed as filtrate moves through the nephron system. The filtrate gets processed before we generate urine. Urine is what we excrete from the body. So filtrate is what is filtered, and then through a processing through the rest of the nephron, we generate what's called urine. One of the processes that happens throughout the rest of the nephron is reabsorption. Reabsorption is going to move substances from the nephron back into the cardiovascular system. So notice the arrows, we're moving back into the blood. So reabsorption is nephron to blood. So wherever you see reabsorption, remember it's nephron to blood, putting things back into the cardiovascular system. So we're moving things into the paratubular and vasa recta capillaries. Secretion is a mechanism for moving material from the blood back into the nephron. So notice the direction of the arrows. We're going from the blood back into the nephron system. So if you're secreting, then you are moving those molecules back into the nephron, and so they are destined for excretion. These reabsorption and secretion processes are selective. They're based on transport mechanisms. So what is essentially the nephron doing throughout the day? Well, the kidneys filter about 125 milliliters per minute. So that's a high filtration rate. We're filtering about 125 milliliters per minute. That works out to be about 180 liters of volume per day, which actually would be way too much volume to lose from the body. So we have a very high filtration rate, but we have very little urine output for the day. That means that we must be taking back a lot of the volume that gets filtered. Notice the concentration of the filtrate is about the same as what human blood is. So human blood is about 300 milliosmoles, and the filtrate that we produce is about 300 milliosmoles. So we're talking about an isoosmotic filtration. About 70% of the volume gets reabsorbed in the proximal convoluted tubule. And in the proximal convoluted tubule, we are essentially taking back electrolytes, water, nutrients that we want to hang on to, so glucose, amino acids, essentially keep the good stuff and allow the waste material to continue moving on through the nephron system. So because we are reabsorbing so much fluid and material, right, there's only about 30% of the volume left once you get past the proximal convoluted tubule. So you have about 180 liters per day that's being filtered, but by the time you reach the nephron loop, you're down to 54 liters per day, or about 30% of that volume. The loop of Henle continues to reabsorb. It reabsorbs proportionately more solutes than it does water. And so the filtrate can actually become hypoosmotic as you move through the nephron loop. Now, that can vary depending upon what processes are taking place in the nephron loop. But on average, what we see is by the time the nephron loop has processed, we're left with about 18 liters of volume per day. That works out to be about 10%. Right? So 10% of the volume that we filtered actually makes it into the distal convoluted tubule. And typically, we're talking about a hypoosmotic concentration. So rather than being 300, we're down to about 100 milliosmoles. In the distal convoluted tubule and the collecting ducts, we tend to have more hormonal regulation taking place. This is where you see the effects of antidiuretic hormone, aldosterone. We are making adjustments to the fluid that's in the distal convoluted tubule. We may be secreting things into the distal convoluted tubule. So we're making adjustments to the fluid in the nephron to eventually determine what the urine output is going to look like. By the time material reaches the collecting duct and is getting ready to be excreted from the body, typically we're only looking at about 1.5 liters of volume being excreted per day. That's going to be less than 1%. Right? So that's going to be less than 1% of the total volume that you actually filtered for the day. So you're actually not losing much volume. The actual concentration of what you excrete will vary, again, depending upon what's going on in the body at that time. So you can have very hypoosmotic or you can have hyperosmotic urine, depending upon the electrolyte and water balancing that's taking place. So how do we determine what's being excreted from the kidneys? Well, a simple way to look at that is to look at filtration minus reabsorption plus secretion is going to determine what is excreted from the body. So we filter, we reabsorb back into the cardiovascular system, we secrete out of the cardiovascular system, and that's going to determine what is excreted from the body. So for example, if we filter, let's say we filter 100 millimoles of potassium. Let's say we reabsorb 50 millimoles of potassium. So that's minus, because we're putting it back into the cardiovascular system. Let's say we secrete 10 millimoles of potassium. Then our final excretion would be 100 minus 50, so 50, plus 10, so that would be 60 millimoles of potassium being excreted from the body. So we can look at what is filtered minus what gets reabsorbed and put back into the cardiovascular system, plus whatever we put back in the nephron, secretion, to determine what is excreted from the body. So that's a little bit on general functions of the kidneys and the processes that take place in the kidneys. I hope that helps. Take care.